All right, how would I figure out Biff's percentile?
You got find count and then 65 and divided by
Yes, so Biff's score is one of these two 65s. I don't know which one it is. I'm going to grab everything that is his score or lower. So I'm going to grab both of those 65s and the 61. So 3 students scored a 65 or lower. How do I use that information then to find the percentile?
you get a decimal and that's the percent.
Yep, so right now I just have a 3. How do I take it from a 3 into a decimal to get my percent? Divide it by 20, yes. Sorry, I don't think my question was very clear, and I apologize for that.
I think we're saying the same thing. Where it came from.
Got it. Okay, so we know that the total number of students is 20. That's what that N is 20 means there, random sample of 20. So we're going to take the 3 students that scored a 65 or lower. We're going to divide that by 20, and you get what as your decimal? 0.15. So he is at what?
50.
Yes, at the 15th percentile. He is at the 15th percentile. And like we talked about yesterday, when we're talking about percentiles, you are at a percentile, not in it. Because it's like describing your location out in the world. We would not be in 71st and Georgetown, but we could be at 71st and Georgetown. So just for clarity's sake here, we want all the students at or below that score to find the percentile. Was Biff above or below the mean? Below. By how many points? 15. Below by 15 points. So how many standard deviations away is he below the mean? 1.5. Tell me how you found that. That's absolutely correct.
The standard deviation is 10. So if there's 2 standard deviations, that would be 20 points away from the mean. But he's only 15, so you have to 10 and then you divide it in half.
That is absolutely correct, Jenna. So 15 points away from the mean divided by 10. This is our standard deviation. And we get 1.5 standard deviations below the mean. And then we asked a very similar question about Mary. Or Marty. I'm sorry, I totally did not see the T. Does anybody watch old movies? Is anybody catching the movie references here? Back to the Future. This is Biff and Marty from Back to the Future. Sorry, I misread the name and then I was like, Biff, that's such a... It's Marty, not Mary. Okay. Yeah. All right. So Marty scored an 88. What is Marty's percentile? You said 80th percentile? Yep. So there are 16 students with scores of 88 or below. And so we would take 16, divide it by 20. We get 0.8. So he is at the 80th percentile. So far, so good with those two parts? Is Marty above or below the standard deviation? Or sorry, above or below the mean? Above the mean. By how many points? 8. He is above by 8 points. So how many standard deviations above the mean is he? 0.8. We do 8 points divided by our standard deviation of 10. We get 0.8 standard deviations above the mean. We have been calculating a z-score. You didn't know it, but I had you calculating something called a z-score. To find a z-score, we're going to take our value, whatever that value is. So like Biff's 60, what was it, 65? Yeah. And Marty's 88. So these individual values. We are going to subtract the mean. And while I didn't actually have you write down a subtraction for me, or subtraction problem, I said, how far above or below the mean is it? And so you found that difference. And then we're dividing it by what? Divide it by the standard deviation. By definition, that is what a z-score is. A z-score tells me how many standard deviations away from the mean a particular value is. So how far away from the center is it? Or how far away from average? When we're talking about z-scores, we always use the mean. We don't use the median with a z-score, because I specifically want to know how far from average is this. Does that make sense? Okay. Let's look at number 6, and then I want to go back and add a couple notes to things that we did earlier. Goldie scored a 98 on the Chapter 1 test. We want to find and interpret this z-score. So how do I find the z-score again?
You have to value minus mean divided by standard deviation.
Yes, value minus mean divided by the standard deviation. What is the value for Goldie's test? 98. I want to know how far away it is from the mean.
80.
Yep, so I'm going to subtract, you said it's 80, there's our mean, and divide by our standard deviation, which is 10. So I get, what, 18 divided by 10? 1.8. So that is the z-score. I need to interpret this now in the context of the problem. Let me see if I can get this up a little bit higher on my screen. I think I can. There we go. Fill in those pieces.
1.8 standard deviations above the mean.
1.8 standard deviations above the mean. Remember, we always want to work context into any interpretation. So what is 1.8 standard deviations above the mean?
Score.
Whose score?
Goldie's.
Goldie's test score was 1.8 standard deviations above the mean. Goldie's Chapter 1 test score is 1.8 standard deviations above the mean. Please, please, please make sure anytime I'm asking you to interpret anything at all context is super, super, super important. So that's coming from this part right here. Make sure you are always including that. You also always need to make sure to include either above or below. Make sure you're including above or below there. Goldie's was above, but for any of the others, as I'm interpreting those in context, I would want to state which direction. So far, so good? Okay. So I wanted to go back here for just a moment where we calculated Biff and Marty's z-scores. For Biff, we said he was 1.5 standard deviations below the mean, right? So our z-score there would be negative 1.5. It is below the mean, so it is a negative z-score. So how would we talk about the z-score for Marty then? What would his z-score be?
Positive 1.8 above the mean.
Positive 1.8? We got the negative 1.5 for Biff because when I divided, I got 1.5 standard deviations. What was Marty's again?
Oh, I'm looking at the wrong.
0.8. Sorry, I felt like I was getting a mix of two different answers, and I just wanted to make sure that I was clarifying here. The z-score is coming from this. If it is above, it's going to be a positive. If it is below, it's going to be a negative z-score here. Okay? So Marty's z-score would be 0.8, and it is above the mean, so it is positive. What questions do you guys have about this front side? You feel like it's been reasonably straightforward?
Yeah.
Okay. Let's flip it over on the back. All right, hold on. I want to get a little note in here that goes up on the notes. Here's my z-score. All right, on the back. There are two different mathematical operations that are being used when we are calculating the z-score. First, up in the numerator, we take each score and do what with the mean? Subtract. So I want to look at this table. This is all 20 students. And I want to fill this in with their score minus mean, so the difference from the mean. Remember, the mean was 80. Grab your calculators if you need to. I would. 61 minus 80 would give me what? Negative 19. 65 minus 80. Negative 15, and that's going to go in both of these. 73 minus 80? Negative 7. 75 minus 80? Negative 5. And then we have what for the next box? Negative 3. The next two boxes are identical. Negative 2 and negative 2. Negative 1. What do I put for the 80s? 0. And then the 81s get a difference of 1. 88 is a difference of 8. 89 is a difference of 9. Then we have 13, 18, and 19. I want to use that to make a dot plot. So I want a dot plot for the score, and I want a dot plot for the score minus mean. So these values right here, I'm going to put on this dot plot, and these values I'm going to put on this dot plot here. Dot plot for score minus mean. So for the score, I need a dot for each of those tests. I need a dot at 61. Dots at 65. Looks like they're counting by twos. I want you guys to go ahead and make those two dot plots, and then we will compare yours to mine. I got mine finished, so you can look up at the screen when you're done with yours to compare yours to mine. As you look at these two dot plots, just from a visual perspective, what's different about them? Shape looks exactly the same, right?
Yeah.
I'm going to write that down. Shape stayed the same. Is the center the same? What happened to the center? It got smaller. It used to be where? In that first distribution, the center is where? 80. Here's the center of my first distribution. It was our mean. For the second distribution, my center is 0. So the center shifted down by 80. Did my distribution get closer together at all? No, it's just that whole thing slid down the number line 80 spots. So it shifted down 80. And I'm going to say 80 points. So the mean of this new distribution, the center of the new distribution, we would describe as what? Gentlemen, eyes up here, please. The center, the mean of just the raw scores was 80. Where is the center, the mean, for the score minus mean?
0.
At 0. We shifted it down 80 points. What about the variability? The spread.
The same.
It's the same. How could I check that? We could do IQR. What's another way I could check spread just like real quick here? We could look, yeah, we could calculate our standard deviation. Looking at this, I would say the fastest thing that I could do just like off the bat is to check, like, did my maximums and minimums, are they farther apart or not as far apart? So I could do a real quick range check, because if it has the exact same range, then I know it didn't squish together at all, right? What is the range of just the raw scores, what we did in red?
38.
38, so check my range. We would do 99 minus 61. We get 38 there. What about for after we did the score minus mean? Yeah. It goes up to 19, right? It goes down to what? Negative 19. When I subtract a negative, that does what? Turns it to a positive, so I get a positive 38 here. That would be a very, very quick way of checking that we didn't actually squish these things together at all, that it does have the exact same spread. All right, so that's one operation that was happening there. We subtracted. What was the other operation that we were doing on the front side of this page? We didn't just subtract.
Division.
Division by what?
The standard deviation.
Yes. We divided by the standard deviation. All right. You guys okay if I kind of shift things up a little higher on my screen? Okay. So I'm going to put divide here. All right, so right here they have recopied that table from up above where we did the score minus the mean. I want to take all of these and divide them by our standard deviation. Remember, our standard deviation was 10 here. And I want to write down that new value. So what is negative 19 divided by 10?
Negative 1.9.
Negative 1.9. Negative 15 divided by 10? Negative 1.5. Go ahead and fill in the rest of this table. And then I want you to make a dot plot for that bottom row, what I'm writing in green. What'd you say?
I said, looks like the same again.
I like it. Can you say that just a little louder?
It's the same again.
It's the same again. As I'm describing what happened to the shape, center, and variability when we divided, so I'm comparing this to the score minus mean, what we did in red up above. My shape stayed the same. My center stayed the same. The center is still where? At 0. Although technically we did 0 divided by 10, right?
Yeah.
Okay, so I'm going to actually write that down. Technically 0 divided by 10. So we still get 0, yes. What about my variability?
That shifted down to 3.8.
Yeah. Variability decreased. How did you come up with that value that you gave me for the decrease? I like it.
I took 1.9 and added in the negative 1.9 since when you subtract 2.
Yep. 1.9 minus negative 1.9. That would be my range if I'm comparing those. And so I got 3.8. So how would you describe the change in variability? It decreased by what? Dividing by 10. When I divide something by 10, that would be 10%. So it decreased by 10%. Or not, I'm not talking about subtracting, but like it shrunk down to 10%. So decreased by dividing by 10 is what I think I'm going to do just for clarity's sake. Decreased by dividing by 10. So to kind of summarize those ideas there, if you add or subtract the same value from each of our data points, what happens to my overall distribution? Let me go back and look at this. This one right here, where we subtracted the same number, we subtracted the mean, but we subtracted the same number from each of these data points. What happened to my distribution? How did it change? How did it stay the same?
The shape stayed the same, but the mean decreased.
Yes. So when we add or subtract, my entire distribution is going to either shift up if we're adding or shift down if we're subtracting. But the shape and the variability stay exactly the same. So the center will change, shape and variability stay the same. Center plus or minus whatever our value A is. It says if we subtract the same value A from each piece. What about if we multiply or divide by the same value? Look at this guy right here, because this is where we divided, right? Variability changes. Does my shape or center change? No. Shape and center are going to stay the same. Variability. Although, if my center is not at 0, would my center change?
Yeah.
If I take something other than 0 and divide it, will it change in value? Yes. So my shape will stay the same. If my center is anything other than 0, this will be affected multiply or divide by whatever our b value is. That's just what they're calling the number that we're multiplying or dividing by. And my variability will also change by multiplying or dividing by b. When I'm talking about z-scores, because we are always going to be subtracting the mean, where will that shift the center to when I'm talking about a z-value?
Yeah.
It's going to shift it down to what? Look at what happened on our other distributions. Here's the mean, right? When I subtracted the mean from the mean, it went to, yeah, if I take the mean value and I subtract the mean from it, it's going to go to 0. The center, when I subtract the mean, is always going to go to 0 on a z-score. So the mean will be 0. When I divide by the standard deviation, what that does is it's going to make the standard deviation of this new distribution that I'm looking at with the same shape. It's going to change my standard deviation to 1. My standard deviation is going to become 1 in this shifted distribution. So we know our z-value is mean minus standard deviation. That means if the value that I had that was the old mean, I'm going to write down what I've kind of said in words a couple times. Z-score, if I have the mean and I subtract the mean from it and divide by the standard deviation, I'm going to get a value of 0 if my value is the same as the mean. Standardized distribution, that is what a z-score is. Please go ahead and write that down. This is a standardized distribution. Z-scores always have a mean of 0 and a standard deviation of 1. This is so when you're looking at a lot of different studies, you're looking at a lot of different information, if they have these standardized scores, you have this point of reference. If they say, oh, it's 1.8 standard deviations above the mean, you can use that same mental scale as you compare different things. Does that make sense? I want to be able to take the same metrics that I'm using in my mind to understand one situation, and I want to be able to apply it to a new situation. I can do that if the scores have been standardized. All right, a couple things that we still need to write down. Next page, with our last couple minutes. Standardized values, z-scores. Z is what? How do I standardize this? Yep, I'm going to take my value, whatever data value I'm interested in. I'm going to do what to it? I'm going to subtract the mean, and then I will divide by the standard deviation. And then when I'm asked to describe that, I would say whatever kind of context. So like when we were describing Goldie's test score, or Goldie's chapter 1 test score is, and then I have to name the z-score. Standard deviations. And then I need either above or below. The mean. This is what I'm expecting to see if I ask you to interpret the z-scoring context. So-and-so's score, or this team's average, or whatever we're looking at in our context, is however many standard deviations above or below the mean. All right, other big idea here. Given any distribution, if we add or subtract a constant, my shape and variability stay the same. Center shifts up or down by A. Multiplying or dividing by a constant. I'm going to call this one B. Shape stays the same. The center and the variability will be my value divided by B. Center and variability will multiply or divide by B. Your first homework is due on Monday. If you do not yet know how to submit homeworks as a PDF, please let me know. I'm more than happy to show you how to do that. It's due by Monday, end of day, so if you work on it over the weekend and you have questions, please bring those to class on Monday. Also, on Monday, you guys will get to see your tests, and we'll talk about the scoring on that, because I told you there would be a curve. I will explain all of that to you on Monday when I have a chance to show it to you, okay?